And I'll introduce Greg Sarangel. He's from Xerxes. Greg's the regional sales manager for Xerxes, located in Waretown, New Jersey. He has over 30 years of industry experience with underground fueling systems design, installation, training, and maintenance. His professional focus since 1982 has been in the fiberglass underground storage tank and leak detection system industry. So when Greg goes home, his house is made of fiberglass. He is Mr. Fiberglass. So with that, I'll give you to Greg.
Well, thank you, John. And I'd like to thank the association for allowing us to come and visit with you today. And hopefully at the end of our program, we'll leave you with just a little more knowledge about our industry and what we try to do to keep a very high standard, at least from the installation standpoint, in the industry. So just introductions. Greg Sarangel. I already had my bio read. With me today also is Todd Bogenreef. He's with Containment Solutions. We're the two, basically the two suppliers in the industry that make and supply fiberglass tanks. So we are really here today to represent our trade association, which is the Fiberglass Pipe and Tank Institute. Member companies, well, I'll get into that, but fundamentally, the Institute represents tanks, piping, municipal pipe manufacturers, and generally anyone that is in the composites industry that is making non-corrosive products, introducing them to all kinds of liquid handling and storage. So a quick agenda. I'm going to give you a quick little overview of the Fiberglass Pipe and Tank Institute. We're going to this is not designed to be our formal training program. They take about 4.5 hours to run. So clearly we don't have that type of time. But we're going to go through the resources that are available to the industry and just give you a flavor of what's available. Also, we'll talk a little bit about taking our program on a local level to you folks. We'd be more than glad to run the full training program on a local basis for any state that might want to have their teams participate in it. And then, of course, we'll be here for some questions and answers at the end of Todd and my presentations. So anyway, like any good organization, we have a mission statement. And fundamentally, the Fiberglass Pipe and Tank Institute is a best practices organization. It's got member companies, Containment Solutions, Xerxes, Amaron, A.O. Smith Piping, a number of other members. And the mission of the association, again, is to disseminate information about our industry and all the best practices that are available. So, again, I already rattled off the member companies. Outside of the petroleum industry, it's not only a petroleum trade association. You have companies like LF Manufacturing, Hobus Pipe. These folks typically work in more the municipal water, wastewater area, but they're also member companies. Along with manufacturers, many of our raw material suppliers are involved as well. So it's really a team effort, again, through the association to bring out an overall best practices position for our industry. Just going to talk a little bit about standards. Want to be clear that all the member companies really adhere to the very highest standards available in the industry. For petroleum, typically it'd be UL 1316. For oil water separators, that would be UL 2215. For our piping members, it's UL 971. Only members that can manage to meet these high standards really participate in the association. I'm not going to run through all these, but in our wastewater membership, they also adhere to very high quality and manufacturing standards. So I would encourage you as a group to use the Fiberglass Pipe and Tank Institute as a resource. There's a lot of great history and technical information available through the Institute, which is, again, non-biased, non-manufacturer slanted. It's all really very, very well vetted out and agreed to by all the member companies. So when you look at a recommended practice or a standard that the Institute has available, you know that the member companies have all approved it and all abide by it. So I would just encourage you to take some time outside of this meeting to visit the Institute website. Along with standards, there's a lot of white papers, and we get a lot of phone calls, and I'm sure Todd does too. Tell me about ethanol compatibility. And I think Todd's up tomorrow talking about that. So I will talk about it. What about microbial influence corrosion? Is there any impact on the materials that you supply? A number of very good white papers that answer a lot of the questions that we field every day from either customers, regulators, or owners of underground storage tanks. So again, as a resource, I'd encourage you to go to the website there and review any of those white papers that might be of interest to you. Also, again, tanks, overfill, other topics. Our member company for the piping side, it's not here, but today, but maybe at a future seminar, the A.O. Smith and Amaron folks will be here. Just by way of inclusion, I'll tell you that they have a very formalized training program as well, and I'd encourage you to at some time maybe contact the local folks from them if you're interested in additional information on their training programs. So, kind of get into the more meat of it. Fiberglass tanks, installation materials, and training. It's a we have a very formalized program for field contractors. It's made up of written materials, shipping documents, labeling of the tanks, and instructions to ensure that we get proper installation. No matter how well any of us produce a product, if we don't get proper installation, it's not going to function long-term properly. The programs typically cover critical steps in the installation. We emphasize the use of checklists. It's a recipe, a menu for doing the job right. If an installing contractor can answer yes to every question that's on our checklist, we have a reasonably high expectation that tank or piece of pipe is going to go in the ground and function properly for many, many, many years. I'll point out that there is a variance approval process. We cannot cover every single scenario in a written document or a training program. It's the real world. You dig a hole, you find that there will be an anomaly. There may be a backfill material that's never been spec'd or cited by any of the member companies, but it's a perfectly good material. Could be $10 a ton versus $40 a ton. So we offer as a service to the industry the ability to ask for a variance. But as regulators and inspectors, I'd encourage you that the written word is pretty much what you should subscribe to. If you see things that aren't like what is published or what we've explained to you already, I would say ask that person, have you got a variance to do this differently? We offer that service, but again, it's on an individual basis. I'll talk a little bit about the training program itself, and at the end of these slides, I actually have a sample of the video that we would use as part of that 4-hour classroom training program. Then a little bit about the documentation that we publish. So, kind of starting out to give you some flavor. No one can ever say that they did not get the instructions on how to properly install the tank. That's part of the UL labeling requirement and internal requirements. All tanks come with the installation instructions laminated to them. So anytime someone says, well, you didn't tell me what to do, that's not true. It's always there right on the tank. The other thing we would stress is that, there's various labeling on the tank. Do not overpressurize. Do not lift here. Use these lifting lugs to safely handle the tank. And I would encourage you, any tanks you see, always look for the UL label. That is the gold standard. That is your assurance that that tank meets the requirements to store the materials intended for. It's been properly constructed, it's been tested, and it's got the engineering behind it to give long service life. All right, along with putting the instructions on the tank, we send a complete package of material with each and every shipment. So in that package will be shipping documents, a written copy of an installation manual, which is a 35, 40-page document, covers just about everything we've ever run into. There are clearly two different companies, at least in the tank business, two different brands, but the information contained virtually identical. I mean, if someone tells me that they have sat through a containment solutions training program, I'm fairly confident that they're capable, and vice versa. If they're certified as a Xerxes installer, I think Containment Solutions is very comfortable that they can install their tanks as well. I mentioned checklist. It's kind of the heart of the training program, in that we want installing contractors to provide a written record for the owner, particularly, that they hit all the benchmarks. And it's very important in a follow-up situation that if we get a call, some kind of warranty issue, or the installation isn't performing well, it's really one of the first things that we'll ask for, because it's a record that the job was originally done properly. Summarizes critical steps in the installation: pre-installation testing, backfilling, spacing on the tanks, post-installation testing, deflection readings, ensuring that the tank geometry is good from the first day that that tank's installed. All that gets documented and should be retained by the owner. I talked about the variance program. As I said before, we operate in kind of an imperfect world. You would think that, well, there's not much difference between installation A and installation B, but you'd be surprised. We get all kinds of requests. Can I do this? Can I do that? I have dead men. Can I set them on top of the backfill instead of on the base of the installation? Again, as I say, we try and work from a set of written standards, but we're also in the real world. We know that people encounter problems. So we will, again, create a variance situation, but I would, again, highly recommend that if it doesn't meet the published standards, and you're responsible for oversight on the job, that I'd ask them, make sure that they've got a variance for what they want to change from the manufacturer. So I talked a little bit about the program itself. The full-on training program is really about a 4.5 hour process. It's a classroom style setting, it's PowerPoints, it's video. There is a compliance test, a competency test that we issue at the end of these training programs. Usually that's when I get everybody in the room's attention. They think they're just going to sit there for 3 hours and listen to me jabber on, or listen to a video, get up and leave. Well, when they understand that there's a competency test at the end of it, everybody kind of sits up and you get their attention. So within this training program, we review all key installation procedures. As I said, we use different types of media to make it happen. Basically, we want to cover planning for the installation, handling tanks, everything in the process where something could go wrong. Pre-installation inspection of the tanks. Typically, we're running these tanks anywhere from a few miles from our manufacturing location to 1,200 miles. So a lot can happen from the time it leaves our possession till the time the customer or the contractor receives it. Testing during installation, the physical process of getting them in the ground and backfilled. Then any post-installation testing requirements to ensure that nothing's happened during that part of the process. Then we cover piping, venting, and containment sump attachment, since that's typically considered part of the tank installation, more on the tank side. So it's a very comprehensive set of steps that we cover for each part of the installation process. And as I said, when we tell them that there's a written exam at the end of it, we usually keep their attention for most of the four hours. There's also a documentation program that we have, and I would encourage you that when you're on job sites or you're talking with your stakeholders in the field, that the people that are working for them, putting tanks in the ground, they should be able to document that they've sat through one or both of these programs, as well as the Amaron piece or any other materials that they're putting into the installation. So again, contractor training kits. We have these. We don't just give this stuff out. When you see the term kit, you kind of think, well, here you go, guys, you're on your own. These are really hand-managed efforts by both CSI and Xerxes. We put a high value on getting in front of that contractor and not just handing him a packet and a video and saying, good luck, hope you retain it all. So, as far as what you can look for in the field, you can, this they typically wouldn't take with them. This is a wall certificate. They can frame it, keep it in their office, put it on their desk, whatever. But I would suggest that all of them, our installing contractor base, should be able to produce a wallet card that says that they have been through one of the two programs, or again both, and that they've passed the competency test. So I would recommend that, if in doubt, or if the last thing that contractor did was install a septic tank or something, he may not quite be up to speed to do full-up petroleum installation. So I would recommend that you ask them for the documentation. So, kind of gives you just an overview between the available materials, the documentation, what a contractor should have in his possession out in the field, and the steps involved in the training process itself. What we would kind of encourage, really, is that you use us as an industry resource, individually through the Fiberglass Pipe and Tank Institute, and we'd be more than willing to come out and visit you folks on a local basis, run our program for your staff, and it's really to our benefit. We can't be everywhere. We can't have eyes on every tank we send out the door. So we rely not only on high quality project management teams, but we rely on you folks quite a bit to catch when and if something is a shortcut or someone makes an error. So we would really, again, encourage you as a group to reach out to us and try and arrange, if you so choose, have us come in and offer up the full training program for you and your staff. John's folks in New Jersey had myself and the Amaron representative in, and it was it was almost a full day, I guess, between the two of us.
About two of the two.
Right, but you can ask him on the side without us here. Hopefully, he can tell you that it brought some value. So I'm going to thank you for this portion. We're not going to take questions yet. We're going to do it at the end. But what I wanted to do is just show you as a resource that we have our training video, which is part of the again, the 4-hour program. And I think you'll see that, you know, it takes this whole process step by step and leaves very little to the imagination of what a proper installation should entail and what it should look like. So I think I'll run this. Oh. I hope. Nope. Oh, there we are.
This training video is divided into the following sections. 1. Planning for installation. 2. Handling tanks. 3. Pre-installation inspection. 4. Testing during installation. 5. Installing tanks. 6. Post-installation testing. 7. Piping, venting, and containment sumps. 8. Completing installation. 9. Review. You may find it useful to pause after each section and review the broader requirements as detailed in the installation manual and operating guidelines. Section 1. Planning for installation. The first portion of this video includes certain topics that should be considered before a tank is delivered. These include backfill material selection, excavation requirements, tank anchoring options, taking diameter measurements, and on-site air testing requirements. Refer to the table of contents in the installation manual for the particular section where these topics are discussed in greater detail. Backfill material. Using appropriate backfill material is essential to the successful installation and operation of underground tanks. Using materials other than those specified in the installation manual without our prior written authorization may result in tank failure. Generally, all backfill, from the 12-inch bedding to subgrade, must be either rounded stone or crushed stone that meets the printed specifications. Rounded stone and crushed stone materials are referred to as primary backfill materials in the installation manual. Rounded stone should be a mix of rounded particles from 1/8 inch to 3/4 inch in diameter. Crushed stone should be a mix of angular particles 1/8 inch to 1/2 inch in diameter. Refer to the installation manual for precise backfill specifications, which references ASTM material standards. Excavation requirements. Excavation size is determined based on tank quantity, tank dimensions, along with other key factors explained in the installation manual. Generally speaking, all tanks require a minimum 12-inch thick bedding of approved backfill material. Therefore, key factors for depth of the excavation include bedding, tank diameter, and the required amount of tank cover material, including any concrete or asphalt slabs at grade. Total depth of cover requirements on our tanks range from a minimum of 12 inches to a maximum of 7 feet. Key factors include whether or not the tank will be subjected to traffic loads and whether the excavation and tank will see groundwater. Refer to the installation manual for a specific minimum depth of cover requirements for petroleum tanks. Tank quantity, diameter, size, and soil conditions are key factors in determining tank spacing. In all cases, the minimum spacing distance between the tank and the sides of the excavation shall be 18 inches. In the case of more than one tank in the hole, a minimum of 18 inches between tanks is required as well. Spacing between tanks may be greater if tanks are anchored. If you use dead men for multiple tanks installed side by side, you may have to allow more space between tanks to accommodate the dead men. If the excavation is in unstable soil, for example peat, landfill, soft, or expansive clay, we recommend that the tank owner seek the advice of a local foundation professional engineer. In your plans, make sure to note that spacing between tank and the side walls in unstable soils shall be a minimum of 1/2 the tank diameter. Also, if the surrounding soil is unstable, or if there is a potential for groundwater conditions to fluctuate, geotextile or filter fabric may be required to prevent migration of the bedding material into the native soil or the soil into the bedding. Anchoring tanks. We recommend that every site be thoroughly evaluated for the potential of a rise in the local water table, or of perched or water trapped in the excavation. Sufficient overburden and/or an appropriate anchoring system must be present to offset potential buoyancy of the tank. If an anchoring system is to be used, note that only our anchor straps may be used when anchoring a tank. We have different types of anchor straps options: standard straps and man-out-of-hole straps. Two common types of concrete anchors used are deadmen or an anchor slab. The dimensions of the deadmen and the slab depend on the size of the tank and the depth of burial, and are provided in detail in the installation manual. Consult the dimension tables in the installation manual before excavation so you provide sufficient space. Anchor points are required in the slab or deadmen to connect them to the hold-down straps that will be placed over the tank, on the ribs of the tank. Hold-down strap locations are marked on certain ribs of tanks with marked arrowheads. Plan carefully when locating the anchor points in the slab or deadmen so that they correspond with the tank ribs marked with arrowheads. Our prefabricated deadmen are supplied with 3/4-inch diameter galvanized adjustable anchor points and generally ship on the same trailer as the tank. Taking diameter measurements. At various stages of the installation process, you will be required to take tank diameter measurements. You will take a total of 4 diameter measurements during installation, and you will record these on the installation checklist. An initial measurement of the tank diameter will be taken before installation of the tank begins. This first measurement is used as a comparison reference for subsequent measurements in order to check proper backfill placement and to verify that the installation process is proceeding correctly. Refer to the installation manual for more information on how to take diameter measurements and the allowable tank deflection limits. On-site air testing requirements. At various stages of the installation process, there may be on-site air testing requirements. To air test tanks, you need to construct a test manifold. The air supply gauge must have a maximum full-scale reading of 15 psig. The pressure relief device must be rated to a maximum of 6 psig, or 4 psig for a 12-foot diameter tank, to reduce the risk of overpressurizing the tank. For multi-compartment tanks, you need a test manifold for each compartment. Section 2. Handling tanks. Now that we have explained some general planning considerations, we will begin discussing the installation of tanks, beginning with when the tank arrives on the job site. When the tank arrives at the job site, before unloading a tank, visually inspect it for any shipping or handling damage. You will have to sign the shipping papers provided by the driver. If any damage is observed, this must be noted on the shipping papers before signing. Refer to appendices of the installation manual to determine the dimensions and weight of your tank. Based on tank size and design, some tanks are rotated on the trailer for shipping purposes, while others are not. When the tank is not rotated, that is, when the tank is upright, use all lifting lugs to unload and install the tank. Rotated tanks have extra lifting lugs to aid in the loading-unloading process. Use the lifting lugs that are situated on top of the tank in its rotated position to offload the tank from the truck and place it on the ground. Do not wrap chain or cable around the tank. If necessary, use guide ropes or tag lines to guide the tank. Do not move the tank by rolling it. Select a solid, level area clear of debris where you can place the tank after lifting the tank off the trailer. When placed, chock the tank, for example, with sandbags to stabilize it. Section 3. Pre-installation inspection. Our tanks are tested prior to shipment, but they must be tested on-site prior to installation to make sure they were not damaged during shipment. For all tanks, the first test is a visual inspection. Thoroughly inspect the entire outside of the tank, including the bottom of the tank. Rotate the tank so that you can see the tank bottom. If any damage is detected during this initial inspection or during any part of the tank install, do not attempt repairs. Contact customer service at the manufacturing facility nearest you. Phone numbers are listed on the back cover of the installation manual. Section 4. Testing during installation. After the initial visual inspection, different types of tanks require different tests during the installation process. To help understand which test applies to your tank, we will begin by describing the types of tanks that we manufacture. Next, we will explain how to perform on-site air testing. Finally, we will conclude this section of the training by showing the specific tests that apply to each tank type. The space between the walls of a tank is called the interstitial space. We manufacture tanks with a dry interstitial space or a wet interstitial space, commonly referred to. On dry tanks, there is no fluid in the interstitial space. On wet tanks, we factory fill the space with a calcium chloride monitoring fluid that is dyed blue to differentiate it from other fluids. Both types of tanks are available as single compartment and multi-compartment tanks. The installation manual provides detailed instructions for testing each type of tank, but you should note that all petroleum tanks must be air tested at some point during tank installation. Follow the instructions carefully. Now it is time to learn about on-site air testing. Always remember that air testing a tank can be hazardous to people and property. Carefully read all warnings, cautions, and notices listed in the installation manual, and always notify all people on the test site when an air test is underway. Before air testing, you will remove, clean, and re-dope all factory-furnished temporary plugs with appropriate thread sealant. Then install permanent plugs in all openings where piping will not be installed. Remember also that a service fitting is needed for the test manifold we described earlier. In multi-compartment tanks, a service fitting is needed in each compartment for a test manifold. In wet tanks, do not plug the reservoir fitting when air testing the primary tank. The test pressure must stabilize at 5 psig or 3 psig for a 12-foot diameter tank by adding or removing air as necessary. You must allow for pressure variations when tanks are subject to abrupt temperature changes. When the pressure stabilizes, you will close the valve on the test manifold and disconnect the air supply line. After the pressure stabilizes, the minimum air test duration is 1 hour if you are testing the primary tank or interstitial space. Note that you will never apply air pressure to the interstice of a wet tank. When air testing a dry tank, you must never apply pressure to the interstice directly. Those tanks come with a quick disconnect assembly connected to the interstitial monitor fitting. The assembly consists of a gauge, a valve, and a hose. This assembly is not connected to the primary tank until after the primary tank has been tested. Without releasing the pressure on the primary tank, after testing the primary tank, you will insert the hose into the quick disconnect fitting of the primary tank. This will allow air pressure to flow from the primary tank to the interstitial space. After pressurizing a tank, you will apply a soap solution to the tank to check for leaks. When soaping, watch for active air bubbles, which indicate a leak. If you are applying air pressure to the primary tank, at that time you soap only the fittings and manways. If you have pressurized the interstice of a dry tank, you will soap the entire exterior of the tank. If soaping the entire tank, rotate the tank to check the bottom. Rotate the tank slowly and carefully to avoid developing too much momentum. Make sure the tank's fittings and manways never touch the ground. Do not rotate the tank more than 120 degrees from the tank's upright position. If your air test is successful, you will carefully release the air pressure, remove the test manifold, and continue installing the tank. Now it is time to discuss the specific tests required for each tank type. Testing a wet tank. The first test for this type of tank is a visual inspection of the interior and exterior of each compartment for the presence of monitoring fluid. On the top of the tank, there is also a reservoir. Check that there is monitoring fluid in the reservoir. Measure the level and record the level on the installation checklist. If no monitoring fluid is observed inside or outside of the tank, and you have observed and recorded the level of monitoring fluid in the reservoir, you will conduct an air pressure test of the primary tank when backfill has been brought to the top of the tank. When air testing the primary tank, soap the fittings and manways. Also look for active bubbles in the monitoring fluid of the tank reservoir. Monitor the pressure for 1 hour. Remember, air pressure can never be added to the interstice for this type of tank. Testing a dry tank. Dry tanks are shipped from the factory with the interstitial space under vacuum and are shipped with a gauge assembly attached to the monitor fitting. This allows for monitoring the tank during shipping and handling. The date that the vacuum was applied is on a label near the monitor fitting or on the shipping papers delivered with the tank. You must record the date and vacuum gauge reading on the tank installation checklist. For these tanks, you must meet the following interstitial vacuum requirements. 1. Tank shipped under vacuum must be under vacuum for a minimum of 7 days, as indicated on the shipping documents and/or tank labels. 2. The vacuum gauge shipped with the tank reads at least 12 inches of mercury. If the tank meets both of these requirements, you may continue with tank installation. If the tank fails to meet either of these requirements, or if the tank was not shipped with vacuum on the interstice, you must air test the tank. When air testing a dry tank, you pressurize the primary tank first, soap the fittings and manways, and monitor the pressure for 1 hour. Then, after the primary tank has been tested, use the quick disconnect assembly to pressurize the interstitial space and soap the entire exterior of the tank. You must also monitor the pressure on the interstice for 1 hour. After you have either met the interstitial vacuum requirements or passed the air test, you will conduct an air pressure test of the primary tank when backfill has been brought to the top of the tank. At that time, you pressurize the primary tank, soap the fittings and manways, and monitor the pressure for 1 hour. This concludes the discussion of specific test requirements for each type of tank. If the tank does not pass these tests, or if any damage is detected during any part of the tank install, do not attempt repairs. Contact customer service at the manufacturing facility nearest you. Phone numbers are listed on the back cover of the installation manual. Section 5. Installing tanks. Before beginning tank installation, take a tank diameter measurement. Record this as measurement number 1 on the tank installation checklist. You will measure the diameter again later and compare those measurements to this initial measurement. If geotextile is used, it is placed on top of a slab or under deadmen. If an anchoring system is used, it should be placed in the excavation before the tank. There needs to be 12 inches of approved backfill under the tank as bedding, including when an anchoring system is used. For certain diameter tanks, an option is for the dead men to be placed so the bottoms of the dead men are even with the bottom of the tank, that is, with the dead men placed on top of the bedding material. We are showing standard placement of dead men in this training video. If dead men are being placed on top of the 12 inches of bedding material, you may need to use different turnbuckles and/or use wire rope, depending on the diameter of tank you are installing. If water is standing in the hole, pump water from the excavation hole before placing the tank and continue pumping to maintain minimum water level during tank installation. Attempt to maintain the water level below the top of the bedding materials until the tank can be fully backfilled and ballasted. If the water level in the excavation cannot be lowered, you may have to add ballast to the tank to lower it firmly on the backfill bed. Use only enough ballast to lower the tank until backfill can be added up to the top of the tank. In a dry hole, the ballast level in the tank should always be lower than the backfill level outside the tank. After smoothing and leveling the bedding material, place the tank using the lifting lugs. If dead men are in place, center the tanks between them. Once the tank is in position, place a small amount of backfill under the sides and domes of the tank to stabilize it. If hold-down straps are used, install them at the locations marked with arrowheads on the tank. Tighten all straps uniformly until they are snug, using additional anchoring hardware, such as turnbuckles and/or wire rope. Hardware specifications for each size tank are in the installation manual. After the straps have been installed and tightened, take a tank diameter measurement to check tank deflection and record it as measurement number 2 on the tank installation checklist. Now you are ready to begin backfilling. For a successful tank install, it is critical that the backfill supports the tank, especially from the 5 o'clock to the 7 o'clock positions at the sides of the tank and under the dome tank ends. This will require handwork. Starting with a 12-inch lift of backfill, use probes to push the backfill completely under the sides and domes of the tank, but do not use metal bars. Take care to ensure that there are no backfill voids under the tank. Repeat the same process with another 12 inches of backfill. After 2 12-inch lifts are placed against the tank, you can backfill to the top of the tank without further handwork. When you have finished backfilling to the top of the tank, take another tank diameter measurement. Record it as measurement number 3 in the tank installation checklist, and determine whether tank deflection is within the allowable limits shown in the installation manual. As a precaution, many installers choose to ballast tanks after backfill is brought up to the top of the tank. Section 6. Post-installation testing. You must perform an air test on the primary tank when the backfill is brought to the same level as the top of the tank, soaping just the fittings and manways at this time. On double wall tanks with a wet interstitial space, also check the reservoir for bubbles in the monitoring fluid. Monitor the pressure for 1 hour. If you are going to perform this air test on the primary tank while it is ballasted with water, the tank can be pressurized to the same test pressure that you would use on an empty tank. At this point, all that remains before you can backfill to grade is to add the tank accessories and piping. Section 7. Piping, venting, and containment sumps. The following are some important points with respect to piping and venting. All piping must be...
Stay on schedule. When you get to that last section, you've got a successful tank installation. I mean, from purely a selfish standpoint, everything above that really is out of our domain, which is the proper installation of the containment sumps, of course, is of interest to us, and the piping going out. But fundamentally, you get to that point in the installation, backfill to the top of the tank. That's how that tank should be for the next 30 years without much change. So we get to that point and everything's been done right. We've got a good installation. So that I'm going to turn it over, and we'll have some questions at the end, I hope.
Thanks, Greg. So if you're doing tank installation inspections as part of your program, hopefully you'll learn something. If you're going to just start doing installation inspections like we are in New Jersey, I know we learned something. If you want the full 4 hours, 6 hours, or whatever it took, I really suggest you get a hold of these guys. They'll work around your schedule to, come out and train your staff fully and give them a lot more insight into what a proper install is. Our thought was if we're going to go and check on installers doing this work, we should know a little bit more about what to do. With that, we're going to move to Todd Bogengry from Containment Solutions. Todd is currently the Midwest and Western Canadian Regional Manager for Containment Solutions based in St. John, Indiana. Todd joined CSI in 1995 and held various positions, including Midwest Area Manager before becoming the Regional Manager in 2013. He was previously employed by Owens Corning Fiberglass, Chris Craft Industries, and Nalco Chemical Company. He holds a Bachelor's of Science in Packaging Science from Michigan State University. And welcome, Todd.
And we got to get your slides up.
Yeah. Take those off so I can see. Like this. Next. 2 seconds. All right, thank you. When Greg and I first started talking about this presentation, we knew we wanted to go through the single wall, sump, and tank installation instructions, but we want to take the opportunity to also talk about something that you might come across in the near future as a result of some of the new changes to EPA regulations as it relates to double R sumps. And so we want to talk a little bit about our double wall sumps and collars, a little background on just the product itself, and then a little bit more on the installation because it is a little different than your typical single wall sump. So round double wall collar or double wall collars and sumps come just like our standard single wall collars. They're round. They come in 42 and 48 inch diameter. I do know that on our single wall we do have a 54 inch diameter option, but they are a round collar. The base of our sumps is also round, but the sumps themselves are always going to be polygon. We do not offer a round double wall sump. The reasons for that we'll get to in a minute. The bottom of the polygon sump, and you can see the picture there, transitions to round. Now this is an advantage to you when you're out in the field for a couple reasons. One, with your double wall penetrations going through the sump wall, it's nice to have a flat surface for your penetrations. So the polygon sumps are very important for that purpose. Having the round base allows you to rotate those on the collar to get the orientation of those flat surfaces where you would like them to be for your penetrations. Oops. And so it makes it much easier for whether either the 42 or the 48-inch diameter sump to get your alignments up so you can have a 90-degree angle, 45-degree angle, or a straight angle coming into those sumps for all of your penetrations, which again gives you much better penetration. Don't have any pipes coming in at angles, and so you get a better seal. And with double wall sumps, that's very critical. The other thing you're going to see in all of the double wall collars is going to be a test plug at the bottom of the collar. Now this is a threaded fitting that will actually have a reducer in it and a plug, and you'll see a little bit more why you're going to use that, but every one of those collars has those. One of the first things you need to be doing when these show up is to check to make sure that that's still in place so that it's there. You're going to need that later. And this is designed for doing annual testing. And we use this when they do the testing of these sumps to make sure that there's communication between all levels of the sump. Because when you start talking about a polygon sump system, you've got a collar, you've got a polygon section of your sump, and then you've got the round section at the top. So you've got all three of those that need to communicate. This will let you be able to monitor whether the brine is communicating from the top to the bottom when you do that testing. Now, in a quick synopsis of the installation, and one of the other advantages of using the polygon sumps is the bottom section of your polygon sump is 2 feet tall. So that gets installed onto your collar, and it's at that point that you're going to be putting all of your piping penetrations into the sump. You can hook up your pumps and everything else at this time. But one of the big advantages to doing this, and there's a couple of them, but one of the first ones is you no longer have a confined space issue. You're standing in a sump that's 2 feet tall. It's not a confined space. You can do all your penetrations. You have easy access to everything, both inside the sump and outside the sump. And you have to seal both with a double wall sump, so you need to have that easy access to those. Makes penetrations much easier, which we kind of covered already. And then the other thing that's an advantage, and a really big advantage, is once you've done those penetrations, you can now do a test to make sure that all those penetrations are tight. And this is done before you put the valance of the sump on. And again, not a confined space. If there's an issue with it, you can remove your water from the test, do what you need to do to fix those penetrations, test it again, and then move on as soon as you're tight. There are a couple different options for how the collars or the sumps are attached to the collars, and then the second sections of the sumps are attached to the polygon section. The first one is adhesive channels, which uses the traditional adhesive joint compounds that you see out in the marketplace. This is what a typical system would look like for that, and you'll see basically two adhesive joints, one on the inside wall of the tank, one on the outside wall of the tank. I want to point out one thing that's a little difficult to see. If you look right down in the middle where they go together is a mesh channel. That is a mesh material that we put in that collar so that when you're putting the adhesive in, it doesn't squeeze down in between and underneath there and actually block the flow of the brine through the annular space. So that's an important thing to remember that's in there. So it's something to watch if you're at a job site and they're doing the installation. If you don't see them putting that in there, it's a good idea to ask questions at that point. The other option is a layup joint, which is basically a fiberglass layup. Similar, except that it's going to be a flat surface, two mating surfaces, and we're going to look at a little bit more detail on both of those as we go through here, but I just wanted to give you a quick synopsis of the installation. But this is the second option for doing your joints for both the collar and for the sump itself. The sumps are connected using a fiberglass layup. It's typically 6 inches wide, goes over the joint on both sides, again, inside and out. To keep the resin from going through those joints on this one, what you actually do is on that joint you'll apply a masking tape, typically 1/2 inch, and then you'll glass over the top of that, and that again keeps that resin from going into that annular space, which could preclude or cause blockage of the flow of the fluids in the annular space. All of our double wall sumps, and I think speaking for Greg as well, come with fiberglass lids. They have no mechanical fasteners. They're typically just a gasket with a compression. They have an optional inspection port, which is actually very handy when it comes to doing the testing and stuff like that, because you place that right over the top of where the reservoir is, so you have access to it and you can pull that reservoir sensor out very easily. And the gasket itself, again, is watertight. The reservoir is always going to be in the top of the upper section, and that's the round section of the sump. right at the very top, so it's easy access when it comes time to do inspections and testing. And again, this is where the fitting at the bottom comes in hand. What typically is done now is they will put a valve on that with a clear plastic hose that they bring up and then secure at the top by the reservoir. And the way to check for continuity is to basically open that valve, allow that brain to drain out. It'll come up into the hose. If it's coming through there, you know that it's flowing through. It'll then actually drop the level in the reservoir. So that's a way to know that you've got continuity between the collar, through the polygon section of the sump, and all the way up to the top portion of that sump. The fitting in the top of the reservoirs is the PVC thread. Gives easy access to put things in, to thread the sensors into it. And again, it's at the top, so it's easy to get to, as opposed to putting it outside or at the bottom or someplace else. All the sumps, when they ship, are palletized. And it's important. This is one of the important things when you get to a job site. Single wall sumps a lot of times will come. They'll be on the truck. A couple of guys can usually manhandle those off the truck. Double wall sumps are considerably heavier than a single wall sump, and it's something you're going to have to mechanically unload for safety purposes. And you also want to store them sitting upright, so we palletize those so that it's easier to do that. And again, that just prevents them being damaged while they're on the job site. All right, so installation material, like we have for our tanks and for our single wall sumps, there is an actual double wall sump installation manual. There is actually separate installation training. So if you want to be trained for tanks and double wall sumps, it's actually 2 separate sessions. We can do them at the same time, but it's 2 separate sessions. There's a whole separate set of installation training. We've got a separate video or PowerPoint, depending on which way we're doing it. And then we have a separate test specifically for double wall sumps, and you are registered specifically for double wall sumps. So you will have tank installation training, double wall sump installation training. So you have both. Here's a view of what the 2 installation instructions look like from both of our companies. All right, so quick assembly. One of the key things with double wall sumps, and this is true for single wall sumps too, is always dry fit everything before you start applying adhesives. The thing about these sumps and the adhesive kits that we use for these, or the layups, is once you put them in place, the only way to get them off is to cut them off. So it's basically the old carpenter's rule, measure twice, cut once, because once they're on, they are not coming off. So it's important to do all your dry fitting up front, check your heights and elevations to make sure everything's where you want it before you start putting things together. Determine any length changes you're going to make. On polygon sumps, and even with the double wall sumps as well, all adjustments in height are made on the round section. The polygon section is a set height, cannot be adjusted. So if, say, you've got a 4-foot tall sump, the bottom section is going to be 2 feet, the upper section is going to be 2 feet. If you need to make it something less than 4 feet total, you'll be cutting off the round section of the upper portion of it. The polygon section is not going to be changed. Confirm that everything is going to be level at the top. This really reflects, and when we go through the installation instructions, we talk a lot more detail about this, but when you're making those adjustments on the bottom of that round section, it's important to make your cuts within 1/4-inch increments, otherwise you end up with a leaning tower of Pisa and they're leaning sideways or whatever. So you want to make sure that they're level, because it can adversely affect the reservoir if it's not reasonably level at the top. And then you also want to make sure that that drain fitting at the bottom and the reservoir are positioned so they don't have to be exactly straight up and down, but you want them on the same side of the sump so that when you go to do that annual testing, you're not working on both sides of the sump on the inside. You've got one on the bottom and one pretty much straight up above it. You can be rotated a little bit, but it's a good idea to get those aligned as closely as you can. Again, this is kind of rehashing. If you're going to adjust the sump, you want to make sure you're using the appropriate equipment for that. It's a double wall piece of fiberglass, so you need to use a carbide tip blade or a masonry blade. And in the instructions, we spend a lot of time talking about the safety equipment. Make sure you're wearing the gloves, the safety goggles, and all the other things, the respirator because you're kicking dust up. The sump body extension, again, we're saying the round part is the only part that you trim. Polygon section is always going to be the polygon section. So you make your adjustments on the bottom of your round. And again, within a 1/4-inch increment. So if you're cutting it, you want to mark all the way around it, get a good straight line and cut on that line. You don't want to have it waving all over the place or be 3 inches here and 4 inches over here. Otherwise, it's not going to be straight when you put it on top. If you have gaps that are greater than a 1/4 inch, you have to use a masking tape. And again, you pretty much need to use the masking tape anyway. It's just a good precaution to make sure that you're not getting that resin through that joint and into the annular space. So it's a good idea to just put that on there. Picture coming up a little bit will show you kind of why it's a 1/2 inch, but you've got a 6-inch gap. So There's a very small area that's actually not going to be bound by the fiberglass. Minimum distance on the bottom of your sump. So I talked about the round sump. It's maybe 2 feet tall. The minimum height that can be is 4 inches, which gives you enough. And really what you're doing is making sure you have enough space there to do your fiberglass layup. And you have to have at least that 4 inches to do an appropriate layup of the fiberglass for a layup bonded kit. Like all sumps, you have to sand. I'm not sure if anybody's other than what we've gone through here this morning have been there, but when you're doing collars and sumps, you have to make sure we pre-sand everything before it goes out, but they still, as a contractor, they have to sand all the mating surfaces. So if you're doing the glue channels, inside the glue channels and the bottom of the sump. If you're doing the layups, it's going to be the outside of the sump and then the inside wall of the sump. They have to be sanded, typically just prior to having the laminates or the adhesive applied, because if you let it sit for too long, you have to go back and do it again. Remove rocks, debris. You don't want to have anything in the middle of it. Sand again and clean the mating surfaces. This is what it looks like when you're sanding. It's easy to see where you have and where you haven't sanded because you can see a noticeable difference in the color. And that's true for both of our products. This is what it would look like if you're doing a layup joint. And you can see how they've sanded basically 4 inches on either side of where the joint will be. All right, so adhesive joints, you sand the surface that will be in contact, and again, we went through that. So it's the inside of the glue channel, the bottom of the sump piece going into it, the layup joint, inside and out, 4 inches on either side of the joint. And again, make sure it's clean, make sure it's dry, wipe it down. You don't need to use oil-based solvents. You don't need to use soap and water. You just have to get the debris off. And what works really well, honestly, is if you have an air compressor, just blow it off. That's probably the easiest way to do it. For an adhesive channel, you can see how this is set up. And again, I'll show you how that mesh goes in there. And that goes around 360 degrees. The length that we send for that is actually a little longer than what you're going to need. When they're putting that in there, they have to overlap it just slightly, cut it off, and then tuck it down in so it's flush. But there shouldn't be a gap and it shouldn't overlap. So it's important to get it in there correctly. They don't have to compact it or anything. It just has to be in there tight enough that they can get it in and sit and not have to worry about it falling out. Drain plug in the bottom. It comes set up. If for some reason somebody pulled it out, you want to make sure it's in there. You don't want to go in and get everything put together and start putting the brine into the tank and have it leaking out in the bottom of your sump. So double check to make sure that that's still in place. If you're going to put the valve in there, make sure they put that in there and all the hosing and anything they want to have on it. At a minimum, you want to make sure that the reducer stays in there. You can pull the plug out if you want to test it when you first start putting brine in it to make sure that it's flowing. You can do that, but you just don't remove the fitting itself. Just leave that in place. So adhesive and layup, the instructions, so going through those. Anytime you get one of our kits, whether it's the layup kit or the adhesive channel, you're going to see on the box itself, there's going to be a date. That's the date that kit was actually put together. And then on the checklist, I talked about checklists. We like to have our checklist on there. One of the things when you do, and this is true again for our single wall sumps as well, is you have a place to put the date that we indicate on the kit itself that it was put together and a date that it's going to be installed. You want to make sure that those dates are within 90 days. If it's over 90 days, give us a call. We'll have to send a replacement to you. Now, the only time that's ever really an issue is if you get a job site where for some reason the job got put on hold and those kits have been sitting around for an extended period of time. As a general rule, we're inspecting those before we put them on the truck to make sure that those dates are recent and there shouldn't be any issues with getting them installed within the next 90 days. So again, just to reiterate, put the dates on the kit, when it was put together and when it was being used. Temperature considerations, you've all worked with fiberglass pipe, you've seen sumps. Temperature does have an effect on the way fiberglass is actually put together. The adhesive kits and the layup kits come with very detailed instructions on how much catalyst you apply the resin based on what the temperature is outdoors. It's important to follow those directions. You don't want to be out someplace when it's 95 degrees and put all the catalyst in because that stuff will set up in about 2 minutes. So follow directions to make sure you have the right amount of catalyst added based on what your ambient temperatures are. That being said, even if you're following directions, you're going to have 20 minutes, maybe a little more than that, to actually do the layup or the adhesive. So again, make sure you've got everything in place, you've got all your fittings right, you've done all your checks, measure twice, cut once, so everything's ready. Because again, once you put it on there, it's on. So it'll give you just be ready to go with it. If it's cold, anything below about 50 degrees Fahrenheit, you need to apply supplemental heat to the area where you're doing your bonds. General rules, they'll put the tent and blow warm air into it to keep it warm, but you want to keep it up there. Now, that's not to say that if it's colder and you can't do that, it's not going to cure. It's just going to take considerably longer for that curing process to take place. So this is an adhesive joint. Again, you saw a picture of this. This is a little bit bigger version of it, but you can see the two joints inside and out. You got the mesh down at the bottom, and you got the annular space between those two walls. This is what that joint's going to look like. If you were doing a layup kit, you're going to have it set up, and you will see here, and this is actually without having the fiberglass layup done yet. So you've got the two walls that are butt jointed together. The sumps themselves, when you do a layup joint, come with what we call an H-clip, which you put on the top of the lower piece, and then you set the upper piece down on top of it, and that holds them in place, so you don't have to worry about them shifting while you're working on them. You do the layup, you got your cut, you put your half-inch tape around it, and then you do your layup. And again, we're not getting into all the details on this because it'd take an hour just to go through that, but you'll do your layup, which ends up looking like this. So you've got 3 inches on either side of your joint, and that's been, we're going to lose you.
Sorry.
As long as you didn't roll off the back, we're okay. So you've sanded 4 inches. We ask you to sand 4 inches on either side. Again, the fiberglass matting that you're going to use is 3 inches. You want to have it perfectly as close to center as you can. We know it's going to shift a little one direction or the other, which is why we give the extra inch of sanding. So if you're not exactly perfect, and none of us is, you'll be okay. But you'll have a layup basically on 3 inches. For either of these applications, the typical cure time for it is 5 hours. If you can give it overnight, that's even better. All right, assembled tank sumps, this is what they look like when they're done. And again, you've got the collar at the bottom, polygon section, round section at the top with a reservoir in the upper section in the opening. The two versions here, the left side is using adhesive channels, and the right side is the layup kit. So you can see they're pretty similar, just the way the joints are set up are different. And then all piping and electrical penetrations are supplied by others. You have, the important part about a double wall sump, again, you go back to it, is you're not sealing just the outside, you got to seal the inside as well. They have to be sealed tight. And the annular space of the sump is not connected to the piping or the tank. It is an individual system. And I want to point out here, we've had a lot of discussion about this internally, and I'm sure Greg has probably had it as well. We look at a double wall collar and a double wall sump as a little different animal than our single wall collar and sump. I mean, it is a system that is designed to work as a system. It's a hydraulic system. Get the right word out. It is a complete system, whether you're doing brine or vacuum. At this time, it's our intention to sell double wall collars with our sumps. We're not going to sell double wall collars and no sump, because it's too critical to make sure that you've got all those annular spaces lined up appropriately and everything is working together as a system, to just throw it out there and hope that somebody else's sump is going to work on it, because I don't want that phone call. All right, so I just wanted to throw that out there. Post-assembly test. So this is prior to backfilling. The annular space can be pressure tested up to 3 psi, kind of like a speed limit. I say this when we talk about the tanks too. That's the maximum you can go to. 2 psi is fine. You don't have to go all the way to 3. But you can put a pressure test on to test the annular space in the fittings. And then after pressurizing, just like you do with the tanks, you're going to apply soap to the exterior and look for any leaks. Let it sit for 30 minutes and everything's fine. You can move on with the installation. Monitoring for double wall sumps is done either through hydrostatic monitoring, and there's a couple of solutions available for that. You can either do the typical brine, which is calcium chloride, or you can do propylene glycol. Don't see as much of the propylene glycol as we do the brine. That's still more popular, but there are some places where they choose to use the propylene glycol, and that is a food-grade propylene glycol. I mean, it's actually environmentally friendly. You can drink it if you wanted to, and it's not going to hurt you. Wouldn't encourage it, but you could do it. So those are the two ways to hydrostatically monitor tanks. If you're going to go dry, then you're going to do a vacuum monitor. And for that, you're going to apply a vacuum to the annular space, and to not be more than 10.2 inches of mercury. And you're going to maintain that. If you're going to do a wet sump, whether it's propylene glycol or brine, you need to actually fill the annular space of that sump. This is where that fitting down at the bottom actually can help you a little bit. A couple different ways to do this. I mean, some people will just put a a funnel in it and pour. We actually do offer a Venturi system where it actually helps to draw the air out of the reservoir, or the annular space while it's bringing the brine into it. Works out very well. You can utilize that fitting on the bottom if you need to with the tube to help draw stuff through there. So there's a number of different ways you can do that. That becomes more of a contractor preference, and we have that discussion with them when we're doing the training, and they can tell us which way they think they're going to go. And with that, that's double wall sumps. Are we on time?
We are on time.
Right. All right, so we can open it to questions now.
Questions? In the back there.
So I've been asking the states the same question I'm going to throw out to you guys here. 2447 is a new UL for sumps. Are you guys, you guys, I guess the Fiberglass Institute, considering putting your equipment through that particular UL?
Yeah, we're evaluating it right now. We haven't made a commitment to do it, but we are looking at going through the testing. It's like anything else with UL. You got to go through and look at what the procedure are, what tests you have to do, what the costs are going to be, and the timing and stuff like that. So we're evaluating it right now. If I had to guess, I'd say probably yes. I couldn't tell you what the timing is going to be. I can't speak for Greg, but
We're probably in about the same position.
yeah.
Thank you.
This question is for Todd, I think. The last couple slides went by fast to me. And so testing the interstitial of the double-walled sump, it looked like they were putting test fluid actually in the sump, not in the interstice. Is that right?
No, it's actually in the annular space. At the top of the inside of that sump is an annular. It's a reservoir. Just like on the tanks, you have
Okay.
the reservoir at the top. You have to do the same thing. I mean, there's always a certain amount of normal variation in the level of the brine. And so you put that reservoir in there to allow that fluctuation and quite honestly, a place to be able to monitor it. So when
That's
you put
what
it in,
it
it's
sounded
dry.
like.
You can do the pressure test and the air soak test, and then if you're going to do brine as opposed to the vacuum, you would then install the brine
Okay.
at that point, which is then you're under continuous test, because once the brine's in it, you're testing everything all the time.
That makes sense. I was confused by the picture on the slide, but I get it.
Yeah,
Thanks.
I was thinking we're getting a little behind, so I was trying to get caught up.
We're not. Thank you.
Just one here. Before my question, I was going to say that your regional rep came to Alabama and we did a training for the regulators on pipe fitting.
Was that Bobby Surgeon?
Is Dan Pittman?
Okay, BSA. Okay.
But yeah, we did a really good job. We
Good.
appreciated that.
Yeah, we would encourage you. I mean, if you want it for your groups or whatever groups you want to have, we're more than happy to come out and do the training. I mean, that's one thing, both our companies have been adamant about is, for our purposes, we would rather spend the time training you or the contractor to have the tanks put in properly rather than get a phone call 6 months after it was put in that there's a problem. So we're more than happy to do the training, and quite honestly, we can do it in a number of different ways. I mean, we prefer to do it in person, but I have done webinars, and worst case, we can send you the installation training materials for you to just review yourself if you just want to look at it if you don't have time. But we will not ever quibble about coming out to do training for anybody.
In terms of relevance, like what are some mistakes that you are aware of for in terms of installers?
I'd say the biggest one is not getting the right backfill material. I mean, that's just my experience. I mean, that's a big one.
I would agree that probably the most critical, if the question was what's the most critical point, is getting the tank set undamaged and properly backfilled.
Right.
Beyond that, almost everything else is correctable. Those are critical items that can't be shortcutted in any way.
I've got a question in regards to, anchoring down the fiberglass tanks. And just recently, I've had a 12,000-gallon fiberglass tank removed. And my question is regards to corrosion on some of those brackets or tied down materials, whether anyone else has had issues with that corroding and coming loose, especially, when we're looking at a lot of water in the tank pit.
Yeah. Do you know what they were using for the brackets? Everything we supply is galvanized, so it shouldn't be an issue. It's either galvanized or it's fiberglass, so corrosion shouldn't be an issue. And I'll tell my contractors, I'm like, it doesn't hurt to coat that stuff either. Just as an added precaution.
I wasn't there at the time that we got down to the very bottom, but we did definitely have a hole.
Yeah. You always wonder if sometimes a contractor gets out there and they go out and supply their own come-alongs or turnbuckles or whatever. I mean, the strap itself is probably going to be fine, but if they've used other hardware, it's hard to say what they may have chosen to use.
Yeah, I would suggest you probably encountered just using a standard wire rope, which is an allowable method with clips to attach the fiberglass strap to whatever the dead man on a slab is. A contractor supplied item typically probably wouldn't meet our standards if we were supplying it as a system, and they probably did not put some kind of mastic coating at least as a corrosion barrier on it. That would be my suspicion.
Yeah, the installation instructions themselves, if they're going to follow that route, suggest either stainless steel, galvanized, or coating, or both.
Thank you.
Yep.
Right back here. I was wondering if you would allow the use of the highway concrete barriers for dead men.
So the K-rails, right?
I have seen this.
Yeah.
I've seen it too.
Yeah, I mean, functionally, yeah. I mean, that's one of those questions that's probably a good one to have a conversation with our tech support people and just explain to them what you're looking to do. I honestly don't see why they would have an objection to it.
Okay.
Variance letter.
Yeah, I mean, the issue you're going to get into with that is because of the height. You're not down far enough, so what they would probably tell you to do is you'd probably have to set those down far enough so that the straps are far enough away that you can anchor them. But then you got to deal with how you're going to put your anchor points in, or you're just going to wrap it with wire rope. So, at the end of the day, the dead man anchor systems that we supply are not real expensive. They're real easy to use. And at least in my experience, most people, they just buy them.
And on that topic, people confuse the weight of the dead men as being the actual
That's the big
mechanics to keep the tank in the ground. Really not true. The buoyant force, for argument's sake, a 10,000-gallon tank is going to create about 100,000 pounds of upward force if fully submerged. So when we talk about a dead man system, it's really the width of the dead man and the soil column above it, along with any top slab, that really creates the hold down force. So, 10,000 pounds or 15,000 pounds or 20,000 pounds of concrete isn't really what keeps the tank in the ground. It's the engineering behind the width of the dead man and the soil column above it that really sizes the system. So, if someone thinks just because it's a big old fat, Jersey barrier, you could float those out of the ground too if there's not enough soil over them.
Yeah, if you talk to the Army Corps of Engineers, you need a concrete pad that's about 2 feet wider and longer than the tank and about 4 feet thick.
Thank you.
I assume that all your resins are certified for ethanol and other sorts of alternative fuels, but I'm wondering whether or not they've been tested for compatibility with the decomposition products. For example, ethanol reacts with oxygen and forms acetic acid. Biodiesel decomposes and forms all kinds of strange chemicals, and I wonder about the compatibility of your resins with those decomposition products.
Yeah, I'm not sure I can get into it. You probably need Bill Schneider, our director of R&D, to get into depth on that. I can tell you that the studies that we do were long-term exposure to those products, long enough for them to begin decomposing, and then we test the laminate structures to make sure that they're still sound. So it's elevated temperatures, long periods of time. Again, I don't know what studies you guys do on yours, but...
Well, I mean, if you're referring to some of the stuff that comes out of the, the 2-3-year-old Battelle study, I think.
Yeah.
Well, My answer would be similar to Todd. I mean, that's a kind of an in-depth technical conversation. But UL 1316, lists confines us to a very narrow group of resins. They've all been proof tested through immersion testing. We've got a 30-plus year history where both single wall tanks rated for just no ethanol, E10, or up to E100 have performed very well. So there's the practical side that we're not alarmed that we've got any field data that says the recent changes in fuels, and I say recent, 10 years, has exhibited any negative impact on the tanks.
How about the field reports that we've heard that a number of filters and dispensers have been clogged with glass fibers? That suggests that there's some sort of decomposition, or there could be some sort of decomposition going on. I
cover 27 states, and I get virtually no. I can say I've had no reported problems. Now, if there's hanging hardware in there, if they're getting particulate from metal corrosion, I've heard some of that, but I've not heard of accelerated or advanced corrosion being an issue for us.
Okay.
For the double wall sump, is that a one-time training, or is that also a renewal?
Every 2 years.
Every 2 years for that one as well?
Yep.
And then do you guys have an easy way for us to be able to contact to see if someone's current or not current?
Yeah, we carry a database of everybody who's trained both, whether it's tanks or double wall sump. So we have a database that we can get. You just need to get hold of us and ask, and we can tell you whether they've been recently. In fact, we can tell you when they were last trained. Even if it's been more than 2 years, we can still tell you when the last time they went through the training was.
The first line is the credentials that we talked about, the wild card. They're typically dated, and I will say that we. Maybe we are or we aren't together on this, but we don't certify companies. We certify individuals.
Perfect.
So ABC Contractor, the owner can't go take the test and then say,
all my guys are tested.
Yeah, everybody in my group falls under my training. We train individuals. They can take that training from company A to company B. So it's for the individual. We don't certify the company.
Does the Steel Tank Does the Fiberglass Tank and Piping Institute, do you have a complete system testing protocol that would cover the tanks and systems, the piping all installed?
So you're testing tightness?
Yes.
That was more while it was developed, I think, with Fiberglass Pipe and Tank Institute, but a lot of that's more UL related. I mean, the UL standard is a performance standard, which includes tightness testing. So, I mean, for us to put a UL stamp on a tank, there's a bunch of tests we have to. I mean, it's about a week's worth of tests we have to do before the tank goes out the door. So that's where a lot of the testing, as far as tightness of the tank, is.
Well, I guess what I'm referring to is once a tank and piping has been installed, is there a protocol or guidance that the institute has put together to ensure that the whole system is in fact properly installed and tested together?
Well, I would say for single wall tanks, probably not. I think we would just rely on industry vetted testing methodology, vacuum pressure, height to volume conversions over time. For double wall systems, the institute has a published recommended practice, and both Containment Solutions and Xerxes have vetted it for have vetted it and agree. It's a way to verify an existing double wall tank in the ground with a test procedure. So that is a published recommended practice on the Institute's website. We both have, if it's a brine fill tank, we both have a third-party recognized overfill test where we raise the brine level into the reservoir and fundamentally do a height to volume conversion over time, and then we'll make a leak prediction. In other words, someone calls me and says, the reservoir is dry in the tank. Maybe it was never adjusted properly from the beginning. The first thing we would recommend is that they run. We branded TrueCheck. Do you have a brand name for your?
No.
Okay.
We've got our field service people.
The brine test. Can be performed. So that's an individual company procedure. Then the Fiberglass Pipe and Tank Institute has a vacuum testing procedure that we've both signed off on for a dry interstitial space. So you can go back and check the tank. I can't speak for the piping members, but through the association, you should be able to get an individual test for tanks and an individual test for piping that combined can check the system.
Follow-up question on the certifications of the installers. Is it possible to get a list of those? Because we have a number of certified tank installers in Maine, and was wondering if we could compare the lists. Is it on a website, or is it something that would contact you to?
For us, you'd have to come back through me, and I could have our database searched by state. Yeah, it's not something that we maintain and publish on the website.
Yeah, it's not on our website either. You just contact us and you just tell what state you're looking for. We can send you a current list of trained contractors.
Thank you.
This isn't so much a question, it's kind of a heads up, and so other people, they may all be smarter than us in Illinois, but avoid a mistake that was made with one of our first double wall sump installations on a double wall fiberglass tank, separate manufacturers. Mm-hmm. Yeah. The fiberglass tank came with a single wall collar.
Okay.
So there was no communication at the bottom 7 inches, which is where, if there's going to be anything, that's where it's going to be.
Yeah, I've heard people ask about doing that, and my first question, quite honestly, is why would you want to do that? Because they want our tank with a single wall collar, and that's how they order it. And then they put a double wall sump on it. And as you pointed out, you're not monitoring that joint where the collar attaches to the tank, and you're not really monitoring the joint where the sump attaches to the collar. You're monitoring everything above that.
It's single wall,
but not that. It's literally a single wall collar.
You got 6 inches of single wall material, so you defeated the whole purpose of spending 3 times the amount of money for what's above it.
Yeah. And that's when things first came to light, was a kind of an awkward conversation between our inspector, who called in his field supervisor, the contractor, who called in his engineering consultant, and they're all going, we didn't think of that.
Yeah, no, we as a general rule, like I said, if we're selling you a double wall collar, we're not going to sell you the double wall collar without the sump. We're going to sell you both. Now, if somebody orders a single wall collar and they choose to put a double wall sump on it, I'm not sure we have a lot of control over that, unfortunately.
Right. That would be the problem. If people won't be honest and tell us what they're intended to do on that single wall collar, then that's a point of control we really don't have.
Yes, John, I was just wondering, you said that New Jersey's getting ready to start doing install inspections. Is that right? Correct. North Carolina's been doing it for quite a few years, and I wondered how many states are doing it, or if it's more appropriate to ask who isn't doing it.
What states are doing install inspections? Are doing it. Currently doing it.
Okay, thank you. I was just curious.
Look like about half.
Okay, so my question, I'm going to ask a question, then give you the backup story why I'm asking the question. So the question is, what's the acceptable amount of flex or stretch that you would recommend or allow when tightness testing a tank? So I ask this because we had an ongoing issue for about 2 years at one property. We had a double wall fiberglass tank, and one tester would come in, test the interstitial space. First time it failed, so they hired somebody, a different company. It passed. Then we were kind of like, well, that's strange. So we had somebody else come out, and it failed again. And what we had come to find out that the person who passed it, they had contacted the manufacturer of the tank, and the tank was under warranty, so they were kind of doing everything they could to make the tank pass. And what they were doing was telling them to pull the pressure, and what was happening was the pressure would immediately go to zero. But if you repeated that numerous times, it would slowly reach a point where it was decreasing slower, and after about, we found out later, 6 hours of doing this, the tank would eventually be somewhat stable.
Stabilized.
Yeah. And the long story short is they ended up removing the tank, and it had delaminated near the bottom. And what was happening was when you were pressurizing, when you were putting a vacuum for 6 hours, it was kind of pulling it together with whatever clay and groundwater was together and forming a somewhat seal. So the manufacturer's position was, yes, we can do this because there's flex allowed in the tank when you're testing it. So what is the acceptable amount of flex or stretch that's...
Well, if we're talking about the interstitial space, we would term it, this comes back to my leak detection days before I was a tank guy. It's called the apparent area of the interstitial space. It can change. Now, there are several generations of double wall tank. From us, we're on our third iteration.
As are we. We're probably 5 or 6 at this point.
All right, so we've all got different iterations over the over 25 years. The first generations of double wall tanks fundamentally were a tank floating inside of a tank. They had the materials to be touching, but physically they weren't really mechanically bonded to each other. So, for instance, when tanks are first brine filled at the factory, they may have to relax or exercise till those materials kind of find their happy point. That can change by influences in the field. You send a tank down the road, it's at atmospheric pressure with no load, got a brine level midpoint in the reservoir. You put it in the ground, you add tons of stone around it, you start putting a ballast load with fuel in it, you get water table coming up. That can change what I call the apparent area, how tightly squeezed together the two walls are. So I don't think there is a standard, or there isn't a number. Becomes more of a, I don't want to say intuitive, but you almost need to get the tank quiescent like you would in a lot of tank tightness testing situations, and get whatever pressure methodology you're using, whether it's air pressure, which we don't recommend on dry tanks, or the brine pressure, and that will take some time to stabilize.
I mean, but in this case, the manufacturer is recommending just keep doing it until it passes. So,
Well,
I mean,
keep doing it
how many
until it
hours should the tester spend out there doing it, I guess?
I mean, keep doing it until someone calls me up and says I've had to add 3 gallons of brine after 15 years in the tank for whatever reason. I'm not alarmed. No. Someone calls me up and said that they've added 50 gallons of brine to a 10,000 gallon tank. That sends my radar up. Why did that happen? We would still recommend reestablishing the brine level and running one of the verification checks. If it doesn't pass that, then we're going to do some other kind of investigation. If it's a dry tank, I'd recommend going back to the Fiberglass Pipe and Tank Institute vacuum testing procedure, which is basically pressure decay or vacuum decay over time. And we get a fairly accurate picture of what might be going on with that tank. I mean, I don't know I don't think I was involved in the specific issue that you referenced, but with hundreds of thousands of tanks out there, you're gonna find different situations all the time.
Time for one more. Okay.
As tanks become more sophisticated, we have double wall, even triple wall offerings out there. What's the rationale for not extending the warranty past 30 years?
We're in business to make a profit.
I don't know.
No company in their right mind extends their exposure. 30-year warranty is as generous as you'll find in any commercial product in the world. So fundamentally, we just choose not to.
Yeah, and at the end of the day, I mean, a lot of the tanks are, service life on a typical tank, most of them are out of the ground by 30 years anyway. I mean, at least what I've seen. There are obviously exceptions, but a lot of them get pulled before that point. But as a point of fact, as you were saying, on our chemical tanks, our water tanks, even our septic tanks, they have a 1-year warranty.
So, again, is this group, addressing this group, I won't speak for you, but I think I know that there's an interest in legacy equipment, and how do I get your stakeholders to get motivated to put in today's technology. We keep extending the warranties, and people are going to keep pushing back. So at some point it becomes, impractical and quite honestly, just not a good business decision.
Okay, thanks guys, that was great. 2 quick things. If you have more questions, which there may be, because we had a lot of questions, for these guys, Todd will be here through tomorrow, so he'll be around if you want to talk to him or write your question on a card. The second thing, and don't hate me for this, it's a public service announcement. It's raining and miserable outside. Don't shoot the messenger. So I'll see you guys after lunch.